This last video for 6.1, we get to touch a calculator. So you get to use a calculator to find approximate function values, because even though we want to find exact values, we can only do so of 30, 45, and 60 at this point in time. And so we want to be able to find approximate function values of all the other angles and maybe even check our exact values as well. Don't forget that calculators can do a lot of work for us to do some checking of whether we're doing it right. So the first thing I want to make sure is that everybody's calculator is in degrees. So you'll know it's in degrees because you'll have like a little DEG usually at the top of your screen, or maybe just a D in a box. Or if you have a TI-83, I can't remember whether it tells you do. I'm trying to remember exactly the buttons. It's either setup or math. You go in there and you just make sure that degrees is highlighted. Once you have that done, we're just going to learn how to push the buttons. So the first thing I want you to do is type sine 50. So you find the sine button on your calculator, you hit sine, you type 50, you hit equals. So to 4 decimal places, sine of 50 is 0.7660. Pretty straightforward. The next thing we want to do is, what if I asked you to find the value of cosecant of 50? We do not have a cosecant button in our calculator. So what you have to do is use your knowledge of reciprocals to say that cosecant is the reciprocal of sine, right? And so it's in your formula sheets, right? If you look there, it says cosecant theta. It might be in the chapter 7 stuff, but chapter 6 and 7 are so linked that you can use them both. But it says this on your formula sheet. It says cosecant theta equals 1 over sine theta. So cosecant 50 equals 1 over sine 50. Whatever the angle is stays the same. So to plug this in, we type in 1 divided by sine 50 equals. And we get 1.3054. So now I want you to pause the video and give this next one a go. Plug into your calculator secant 45. So the first thing you have to realize is that secant theta is equal to 1 over cos theta. So I'm going to plug in 1 over cos 45. Oh, 4s, man, they're the bane of my existence. 45. There we go. So now I'm going to type in 1 divided by cos 45 equals, and I get 1.4142. Now we also should know the exact value of secant 45, and so you could plug in that radical approximation and then match it to the decimal. But I can't emphasize enough how important it is to not rely on calculators to find exact values, because if you are going on in math, and who's taking Math 12 without going on in math? Not very many. You know, this is going to be an expectation of you in the next level. You're going to have to know these special triangles. So even though we could do secant 45 in our calculator, use it as a check, but make sure you can use the triangles to find the exact value as well. All right, now we want to do the opposite. Now instead of finding the ratio, so again for this one, what we did is that when you plug in sine 50, it tells you the ratio of the opposite to hypotenuse for every 50-degree triangle. So any triangle, right, that has a 50-degree angle means that the other angle's 40, and this would be 90, has a ratio of opposite of 0.7660 to hypotenuse, which is 1. Right? And what happens is that your calculator actually has this stored in its brain. It knows that the sine of 50 always has a ratio of opposite to hypotenuse of 0.7660, right? So now what we need to do is tell our calculator to do the opposite. Now we want to give it the ratio for maybe opposite to hypotenuse and say, what angle opens up to this ratio? And so the way we do this is that the question would be written like this. It would say sine of D is equal to 0.6543. We want to solve for angle D. What we do is we use a special button on our calculator. It's the inverse sine button. Some people think of it as an opposite operation. They're like, the opposite of sine is inverse sine. I'm like, sure, if that gets you through. But really it's not an operation. Well, it is kind of an operation. It's a table lookup. You want to tell your calculator that you're giving it a ratio and not an angle. Right? We want to tell your calculator, hey, my ratio of opposite to hypotenuse is 0.6543. What angle opens up to that ratio? So the button that they gave you, it's called inverse sine. It's sine to the -1. Some people will call it like arc sine or something different. But it's just telling your calculator, instead of looking up your angle to find your ratio, I'm giving you the ratio. I want you to look up the angle. So when you type into your calculator, second function sine of 0.6543, it's going through its brain and saying, okay, what angle has that ratio of opposite to hypotenuse? And the angle is 40.9 degrees to the nearest tenth. All right, now let's bring in the reciprocals. So what if I wanted secant beta? Well, there is no secant button. So we have to use our knowledge of the following. Now, I've taught this different ways over the years, but I found this is the easiest way to explain it. Secant of any angle is equal to what versus the cos of any angle? So the cos of any angle is adjacent over hypotenuse. That's the one I always remember first. Okay, so cosine of any angle is a ratio of the adjacent to the hypotenuse. The secant of any angle is the reciprocal. It's the ratio of the hypotenuse to the adjacent. So if I know that this is 1.0864 over 1, I know that this is the adjacent and this is the hypotenuse. So what I like to do is say, okay, if I want to do cos beta, I just do the reciprocal. It'd be 1 over 1.0864, so that I can have, there's that 4 again, sorry, 4. So that I can do the ratio of adjacent to hypotenuse. Make sense? So then to plug this in, I just literally do the inverse cos of that ratio. The inverse cos of 1 divided by 1.0864. So let's plug that into our calculator. So we get the inverse cos of 1 divided by 1.0864. And that gives me 23.0 degrees. If that makes no sense to you, another way of doing this is that if you had secant beta equal to 1.0864, you could replace secant beta with 1 over cos beta to make it similar to the questions that we did above. But then you have to solve for beta. So what I would do first is multiply both sides by cos beta. So I'd end up with 1 equals 1.0864 cos beta. And then I would divide by that 1.0864. So I get 1 over 1.0864 equals cos beta. And then I'm at the exact same place that I got to in one step up here. So up to you if the algebraic way, of substituting in the reciprocal makes more sense to you, feel free to do it. Or if you can see that secant is hypotenuse over adjacent, so if I want cos, I just take the reciprocal. Totally up to you. So what I want you to do now is solve this one. So cotan A equals 28.6362. Pause the video. Okay, so for me, I would say that this is over 1, and this is adjacent over opposite. So to do the tan of A, it would be opposite, which is 1, over adjacent, which is 28.6362. Opposite over adjacent. So then I plug into my calculator, A equals the inverse tan of 1 divided by 28.6362. And if I plug this into my calculator, what do I get? Inverse tan bracket 1 divided by 28.6362. I get 2.0 degrees. 2.0 degrees. All right, so then we're on to part 3. Just a couple questions to practice within there.